Okay, welcome to 3.6 Quadratic Function Models. So this learning target is, what we're going to do is create an algebraic model given the key features and a point. What we've seen so far with our applications is we've actually been given equations. So it might be that the equation models something, but the equation's been given to us. So for the first time, we're going to actually start here creating our own equations. And so the first kind that we're going to see before we do this is ones that are generally in the form of a parabola. They'll all be in the form of a parabola. All quadratics are in the form of a parabola. But the ones we're going to see today are going to be more obviously in the form of a parabola. So the question we're going to start with is, how many points do we need to define a quadratic function? So we need to think about that. And you can pause it to think about like the different cases. It all really depends, and the big thing is it's just enough so that you can draw it. So you might be thinking like, I need 3 points or 4 points or 5 points, but it's really just enough so that you can draw it. So one way to do it is if you had 3 points, both zeros. It doesn't have to be zeros, but like if we have the key features of both zeros and a point, so a graph would look like this with these 3 red dots. And there's actually only one parabola that'll go through that, and it would look like that. Okay, so once we have those 2 zeros and then the other point, we have enough to draw it. The other case is the vertex. So you can get away with only 2 points if one of them is the vertex. And if you think about it, and we just have to label this as the vertex. But if that's the vertex and you have another point, you can see that there's only one quadratic, and really the axis of symmetry will tell you that this point has to go on the other side, and you have to cross through there. And so there's only one quadratic that will go through there, and so it's enough to draw it. Now, if it's enough to draw it, we can actually get enough to make the equation as well. And so we're going to see how to make the equation. So we actually look at a bridge with a parabolic shape. The anchors at either end of the bridge are 42 meters apart. So we can see like this is a sample of a bridge, and you can see like maybe this is 42 meters. Maximum height of the bridge is 26. Find the equation that models the shape of the bridge. It's a bit tricky question if you don't have a graph. There's 2 ways to graph this. You can either graph it so that the vertex is right in the middle on the y-intercept, or you can graph it so that the y-intercept is the smaller, or the first anchor. So if we draw an equation, like the easier way to do it is to actually draw it so that x represents the distance from one anchor to the next. And so we're going to have 2 zeros at 0 and 42. And then we know that the maximum height must be in the middle at 21, 26. Now it doesn't talk about the xy axis at all, so notice that we're creating this, but the Cartesian plane, the xy axis, is very, very important. It's a very important tool to use to actually get an equation for this. And so you can see the parabola that's drawn through there. 21, we get 21 because that's right in the middle of 0 and 42, and that's the logical place that the vertex would have to be. And so this is our parabolic arch. Okay, you can see it's not to scale. Like this is 26 and this is 42, so it is more spread out to come down here. So it does actually look a lot more like this. So these are realistic numbers. Okay. So since we have the zeros in the vertex, we can solve this in 2 ways. You only have to do it one way, but if you had the vertex and not the zeros, or the zeros and not the vertex, you'd have to do it in one way. And so we just look at, like, maybe you try it on your own both ways. And so we're just going to work through how to actually solve for this. Okay, so using factored form, remember factored form looks something like this: ax minus s, x minus t. We have an a value in the 2 zeros. You know your 2 zeros are 0 and 42. We don't generally put brackets around x minus 0, so we can write it like this: ax times x minus 42. You don't have to write it like this, but it does help to understand that this is factored form, where one of the zeros is 0. We have a situation where we have an x value, a y value, and an a value, So we actually have to sub in 2 points, or one of the points, and so you can't sub in the zeros. It just isn't going to work. So you have to sub in the other point that you haven't used yet. If you sub in x equals 21 and y equals 26, or f of x equals 26, then you have a situation where you can solve for a. You just get an equation with one unknown. 21 minus 42 is negative 21. If you multiply the 21 by negative 21, you get negative 441. And the a value is 26 over 441. If we wanted to, we can make a decimal for that, but that's enough to just make the equation. So now you can answer other questions like, at 5 meters from one anchor, how high up are you? And you can see how this might be useful for engineers or for architects actually building bridges. Vertex form, we've got the general vertex form. We just start out with that. Sub in the vertex, 21, 26. Now we're in the same situation where we've got an equation, we need to find a. And so we actually have to sub in a point. Now we can't sub in the vertex, so we actually just sub in one of the zeros, 0, 0 or 42, 0. It really doesn't matter. 42, 0 is actually probably easier in this case because you're taking a positive number, subtracting a negative, rather than doing 0 minus 21. But it doesn't really matter. Negative 21 squared is 441. Subtract 26 from both sides. Divide by 441. We get the exact same a value. And we just put it together in the end. Okay? So you see the situation where you can get these two equations. They actually represent the exact same parabola. That's why they have the same a value. If you expanded them out, you get the same answer. But one's in vertex form, one's in factor form. And they're both very useful, though, for subbing in any value for x to get the value for y. So here's your practice.